أعزائي طلاب وطالبات الصف الخامس الابتدائي، أهلا بكم في حلقة جديدة ودرس جديد من مادة العلوم باللغة الإنجليزية تحت رعاية وإشراف وزارة التربية والتعليم. Welcome dear student. In this episode we will going to learn lesson number 4, Magnetism and Electricity. So let's get started. The magnetic effect of electric current. But first I have a question for you. Can we obtain magnetic energy using electric current? And can we generate electric current using a magnet? This is a very important question, and I will tell you the answer. The answer is yes, we can do that. But why? How we can do that? How we can obtain magnetism using electricity, and how we can generate electricity? To answer this question, so let's start our session. The magnetic effect of electric current. So the electric current can be used to generate magnetic field. And to prove that, we have an activity to show the magnetic effect of electric current. So we have here electric wire and small compass. So in normal state, compass will take a fixed direction toward north and south direction. But when a current or electric current flow through the wire, something will happen. So the tools that needed for this activity: a small compass, an insulated wire, a dry battery. Insulated wire mean wire, copper wire, covered with plastic or rubber. So when the wire covered with plastic or rubber or any non-metallic material, it will be insulated. Insulated in Arabic mean معزول، ما يكهربناش. We have here small compass, insulated wire, a dry battery. When we put insulated wire beside the compass and connect the two ends to the two poles of battery, we will notice something. The compass, the magnetic needle in compass will move or will deflect. So we will observe the compass needle deflects. Deflects mean will move. It will take a fixed direction, north and south direction, and when electric current pass through the coil or through the wire, it will deflect. Deflect mean move, change its direction. So we have to notice here, when we turn on electricity, it will deflect. Turn it off, it will take the fixed direction, north and south direction. So what we conclude, the inference here, magnetism can be generated by electricity. And we will use this idea in something called electromagnet. Electromagnet, magnet, electromagnet. It's a magnet used by electricity, or we can get it by using electricity. So what is electromagnet? It is a temporary magnet which is made by the effect of electricity. What is meant by temporary? And we studied several types of magnet, artificial and natural. They are permanent magnet. Permanent magnet, magnet all the time. Magnet doesn't lose its magnetic force or magnetism, while electromagnet is a temporary, limited with time. Magnet for limited time. It is a temporary magnet which is made by the effect of electricity. الإلكترومagnet magnet بنحصل عليه من خلال الكهرباء، وهو ماجنت مؤقت. أول ما أفصل الكهرباء عنه يتحول لحديد عادي من غير أي magnetism. So electromagnet, a temporary magnet. We have to focus, it is a temporary magnet. As we see here in this figure, the electromagnet consists of what? It's a structure. Structure means its components. It consists of a bar of soft iron or wrought iron. Soft iron or wrought iron, like this iron nail. This iron nail made up of soft iron. a twisted copper wire coiling around the bar of iron. Coiling around the bar of iron. Number 3, a battery. Number 3, a battery. So electromagnet consists of 3 things. Iron bar, soft iron bar. Yes, copper wire coiling around the soft iron bar, and source of electricity or battery. So electromagnet, like this one, what is the idea of working? Its idea of working, electromagnet convert electric energy into magnetic energy, takes electric energy and gives us magnetic energy. So when we connect this copper wire to the 2 poles of the battery, an electric current will pass through the coil, and the bar iron, or the iron bar, will be temporary magnet, will be magnet, attract this iron paper clips. So this magnet is temporary magnet. When we cut the electric current or remove one of its end, the iron bar will lose its magnetism immediately and will be a normal iron and will not attract anything without current intensity, without any current. Okay? So here is a question. What will happen when an electric current flows through a wire winding around a soft iron nail? What will happen? What will happen to the iron nail? It will become what? Yes, it will be a temporary magnet. The iron nail becomes a temporary magnet. Magnet for limited time. Here is another question. Give reason soft iron used for making the electromagnet. Why especially soft iron? Because soft iron is very special, because it is lose and gain the electric energy, the magnetic energy very easily. Lose and gain, because the soft iron gains and loses the magnetism very easily. When we turn on electricity, it will become a magnet. And when we cut off the current or the electricity, it will lose its magnetism. So how we can increase magnetic force? Magnetic force is the ability. How we can increase its ability to attract magnetic material? So how we can increase magnetic force of electromagnet? We can increase the magnetism by 2 things. The first one, increasing number of coils. So we have here two electromagnets. One of them have number of coils less than the other. So the electromagnet which have more coils, more turns of copper, it will be stronger. It will be what? Stronger than the other, have a strong force, have strong magnetism. Second, increasing number of batteries. We have here 2 electromagnets. One of them just with 1 battery and the other with 2 batteries. Which one is stronger? This is the question. Who can guess which one is stronger? Yes, we depend on the current intensity. We depend on the quantity of electricity. So 1 battery can give us a quantity of electricity, and 2 batteries give us double electricity. So the electromagnet will be stronger or have a strong force, strong magnetic force. So number 2 is stronger. Here is a question. Give reason the magnetic force of electromagnet increases by increasing number of batteries. Why it increased by increasing number of batteries? We said battery is the source of electric energy, yes. So by increasing electric energy or by increasing current intensity, what will happen to the magnetic energy? Yes, because the intensity of electric current passes through the coil increases. So when current intensity passing through the coil increases, so magnetic energy will increase or magnetic force will increase. So this electromagnet will be able to attract more iron or more magnetic material. So do you think electromagnet is important or not important? I think it's important. Why it's important? Because it is used in many things. So let's start, or let's study uses of electromagnet. Electromagnet used in many things. Making many devices that are used in our daily life, like television and electric bill and mixer, disk driver. So magnet or electromagnet used in making television, mixer, disk driver and electric bill, and they are very important in our life. We cannot imagine our life without TV. So electromagnet makes this TV or used in making TV. Second usage, making big size winches that used in factories to lift heavy iron blocks. So in factories or in lifting scrap cars, they use electromagnet and hang this electromagnet in crane or in winch, and this winch, when we approach this winch toward scrap car, we know cars are made up of iron, so they will get attracted to the magnet. And when we want to release this car, we have just to cut this electric current and the car will be released. So we use here electromagnet, temporary magnet, not a permanent magnet. Why not a permanent magnet? The permanent magnet will attract the car, but we cannot release this car easily because the permanent magnet doesn't lose its magnetism, while temporary magnet can lose its magnetic energy very easily, and it will be very good for this job. So in factories, they use electromagnet to move very heavy blocks of iron, because the magnetic energy of electromagnet have very strong magnetic force, can attract iron or heavy iron blocks. So let's move to the next part of our question, the electric effect of magnet. Can we generate electricity using a magnet? Yes, we can do that. How we can do it? Now we will know. In 19th century, English scientist called Faraday discovered that when a magnet is moved inside a coil of wire, an electric current passes through the coil. Electric current generated inside the coil, and this pointer will deflect. This pointer or this apparatus here called a meter. A meter used to measure current intensity. So we don't have here any batteries, but we have current, we have electricity, and we get it from the movement of this permanent bar magnet. This bar magnet moves inside the coil and generates electric current. So who discovered this thing? A scientist called Faraday. Faraday discovered that we can generate electricity using a magnet. So let's continue. This means that electric energy can be generated by using a magnet. We can generate electricity using a magnet. Faraday used this discovery to make an electric generator known as dynamo. And this is a very important discovery. Faraday made it, and without this discovery, we cannot live this life that we live it. We cannot light our homes and operate our factories because we depend on electricity and depend on dynamo to generate electricity. So what is the dynamo? As we see here, the structure of dynamo. Dynamo consists of copper coils, a magnet, a permanent magnet. The electromagnet, its idea of work, the idea of working the electric generator or dynamo, it changes mechanical energy into kinetic energy. So dynamo changes what? mechanical energy, mean movement, into electric energy. Perfect. So it's wrong here. Electromagnet, it's not electromagnet, it's electric generator. Electric generator used to convert mechanical energy into electric energy. So we noticed here is a movement. The movement will be converted, or will be electric current, will be converted into electric current. Mechanical energy will be electric energy. So the electric current can be generated by two things. In the dynamo, we can move the coil in a magnetic field or moving a magnet around coil. So if we move the coils inside, or we move the coil in a magnetic field, so it will generate electricity. And if we move magnet around the coil, it will also generate electricity. The electric current intensity increases by increasing the movement. When we increase the movement, move faster, the electric current intensity increase. Okay? And we will study examples of dynamo. But before we study examples of dynamo, let's make sure that we know the differences between dynamo and electromagnet. So let's do it. So to make sure we understand the differences between electromagnet and dynamo very clearly, let's explain it in another way. We have here bar of iron, soft iron, or iron nail, and we have copper wire. Of course, it is insulated copper wire coiling around the bar of iron nail. And we have a battery, and we connect the two ends of copper with the battery. So this is iron, and this is copper wire, and this is a battery. Another thing, we have copper wire coiling, coils or turns of copper, and we have electric lamp, and we have a bar magnet. This is the North Pole and this is the South Pole, and the magnet is moving inside and outside the coils. This is copper wires, and this is lamp, and this is magnet. So what is the name of this apparatus, and what is the name of this, and what is the idea of working of this and idea of working of this? Who knows? Yes, perfect. This contains battery and convert electric energy, yes, into magnetic energy. Again, convert electric energy, take electric and give us magnetic energy. So it's called what? Electromagnet. It is electromagnet. Convert electric energy into magnetic energy. The other one, what is called? It's called what? It contains bar of magnet, magnet bar or magnetic bar, and lamp, and it convert kinetic energy, the movement of this bar, into electric energy, and the bulb will be lightened. So this is called dynamo. This is dynamo, while this is electromagnet. So let's continue our episode. So let's continue our lesson. Examples of dynamo. We have the first example, small dynamo. Small dynamo, it's a structure like this dynamo using in a bicycle. It's a structure, a small cylinder that touch the bicycle wheel tire. Touch what? Bicycle wheel tires. Idea of work, it converts mechanical energy, the movement, into electric energy. Uses, generates a small amount of electricity used to lighten the bicycle bulb. So we have a small dynamo used in bicycles to lighten the bicycle bulbs, and it converts mechanical energy into electric energy. The next one, huge dynamo. Huge dynamo like this one. It's a structure, many great coils that turn between two poles of huge magnet. So it's very great and very big. Its idea of work, the same idea of work, convert mechanical energy into electric energy. Uses, it generates large amount of electricity used for lightening cities and operating factories. Okay? There are three types of electric power stations. First, wind electric power station. They use wind energy to move the dynamo. So we have different type of electric power stations, and all of them use movement, but here we use the movement of wind. Use movement of wind to move the dynamo. Number two, thermal fuel electric power station. They use heat energy produced from burning fuel like oil, coal, and natural gas to heat water produces steam or water vapor, which used in moving dynamo. So the movement of steam, the steam move the dynamo, so it will convert kinetic energy into electric energy. Perfect. Number three, nuclear electric power stations. Nuclear electric power stations like this one, they use the heat produced from the nuclear reactors for heating water to produce steam, which is used in moving dynamo. So here we use nuclear electric power station. Now I have questions for you, so you have to be prepared. Let's answer some questions. Are you ready? Okay. Questions on lesson 4, magnetism. Choose the correct answer. The magnet which is made by effect of electricity called what? Magnet, effect by electricity. Magnet and electricity called electromagnet or natural magnet or magnetic substance. Yes, it is electromagnet, right. Question number 2. The magnetic force of electromagnet will be lost by, we will lose the magnetism by what? Increasing number of coils turns? No, by increasing number of coils turns, magnetic force increase or magnetism increase. So it's not this. Increasing number of batteries also will increase the magnetic force, and it's not the correct answer. Cutting electric current, and when we cut electric current, electromagnet will lose its magnetic energy. Question number 3, the coil of dynamo is made up of wire, copper, carbon, or plastic. It is made up of insulated copper wire. Perfect, copper. Number 4 is the scientist who made the dynamo. Which one? William Gilbert? No, William Gilbert invented compass, right. Faraday or Newton? Yes, Faraday, scientist who made dynamo. Question number 5. The dynamo generates what energy? From mechanical energy. Generate thermal energy, yeah, means heat, light energy, or electrical energy. dynamo generate electrical energy. The last question. An electric current generated in a coil of insulated wire when you move when we move what? Inside coils. Bar magnet, copper bar, or wooden bar? Which one? Yes, it's a bar magnet. So let's review our lesson. Let's go. In our lesson number 4, magnetism and electricity, we learned and we studied that magnetism can be generated using electric current, and electric current also can be generated using magnet and movement. So now we know the differences between electromagnet and dynamo. Electromagnet convert electric energy into magnetic energy, and dynamo generates electricity, and used in small dynamo like bicycle and huge dynamo in electric power station. That's it for this lesson, and see you next episode inshallah.